To state the vertex when something is in vertex form, you flip the first sign and keep the second sign. So that means the vertex is going to be at +2, +1. So to graph it, I'm going to go over 2 and up 1 and put a dot. This is a quadratic function, so the parabola goes through the vertex, it opens up because the leading coefficient is positive. And the transformation from the parent function always starts with the vertex at the origin at 0, 0. So all we have to do is say where that blue dot moved in relation to the black dot. And it moved to the right 2 and up 1 unit. I will demonstrate FOIL for this problem. So we're going to have 4x times x is 4x squared. 4x times -3 is -12x. 5 times x is +5x. And 5 times -3 is -15. Combining the like terms in the middle gives us a final answer of 4x squared minus 7x minus 15. If you did the box method, you'd get the same answer. To complete the square, we can use the completing the square formula, which I'm going to give you on your formula sheet. And that formula is b divided by 2 squared. So this number is b, the 16. So we're going to divide it by 2, which is 8. And 8 squared is 64. For number 26, we're going to add. We will add the real parts with the real parts, and then we will add all the imaginary parts, and we will make sure our answer is in the form where the real parts first and then the imaginary parts second. So the real parts are the 7 and the -3. So 7 minus 3 is 4. And the imaginary parts are 7i and -1i. So 7 minus 1 is 6. So plus 6i. And the real parts first, the imaginary parts second, so we're done. Something similar will happen on the next one. The real parts are -3 and 2. So -3 plus 2 is -1. -8i plus 1i, -8 plus 1 is -7. So the -7i comes second. These next two you have to have a graphing calculator in order to do, which you will have on the exam. So you go to y equals, type in your equation, hit graph, hit zoom 6 if you need to, and when you do that, the graph in number 28 looks something like this. So now we describe it. First, the graph increases, then it decreases. So we can put increases and decreases alternately. It changes directions. Here's one time it changes from going up to down and then down to up. So it changes directions 2 times. It crosses the x-axis 1 time. So there appears to be 1 real 0. Same thing, go back to y equals, clear it out, and type this equation in for number 29, exactly the way you see it. When you do that, your calculator screen should look something like this. So this one starts out by going down and then turning and going up. So it alternately decreases and increases. This one also changes directions 2 times. There's 2 turning points. And it also crosses the x-axis just 1 time, so there's only 1 real 0. Recall the degree tells us the direction the arrows point, whether they point opposite for odd, or if they point the same direction for even. Positive leading coefficients mean the graph ends pointing up, and negative leading coefficients mean the graph ends pointing down. So our arrows are both pointing the same way, which means that the degree is even. and they both are pointing down. So that means that the leading coefficient is negative. If we look at the graph in number 31, both of our arrows are pointing the same way again, and when they point the same, that means your degree is even. And this time they are both pointing up, which means that the leading coefficient is positive. Remember, for odd graphs, if the arrows point opposite, this would be odd, that it's always where the ending arrow is. This ending arrow is up, so the leading coefficient would be positive. If you have a graph that looks like that, the degree would be odd, but the leading coefficient would be negative because it ends pointing down. In order to simplify these with complex numbers, we multiply on top and bottom by the complex conjugate of the denominator. That means we flip that sign from positive to negative or negative to positive. And whatever we multiply by on the bottom, we have to multiply by on the top. So now we have two FOIL or box problems that we need to carry out. I'm going to go ahead and do FOIL. So on the top, I'll do everything in green. To FOIL these two together, we're going to get negative 15 plus 6i plus 20i minus 8i squared. On the bottom, I'm going to also FOIL. You are welcome to box these if you would like. On the bottom, I'm going to get 25 minus 10i plus 10i minus 4i squared. So our next step is to combine like terms and simplify the I squareds. So what I'm noticing here is I can combine those middle terms, I can combine those middle terms, and anytime you see an I squared, you cross it out and replace it with negative 1. So I'm going to do that on the top and on the bottom. Now I'll rewrite what I have. I have negative 15. 6 plus 20 is 26i. And negative 8 times negative 1 is positive 8. On the bottom, I'll do something similar. I have 25. These middle terms cross out. And negative 4 times negative 1 is positive 4. So the very last step is to combine like terms one more time. Negative 15 plus 8 is negative 7 plus 26i. And 25 plus 4 is 29. We cannot simplify 7 divided by 29, nor can we simplify 26 by 29, so that's the final answer. Your first step in 33 is to multiply on top and bottom by negative 5 plus 3i. So go ahead and FOIL the top and FOIL the bottom. When you FOIL, you should get something that looks like that on the top and the bottom. And now we need to combine like terms and replace the I squareds with negative 1s. So go ahead and do that next. Your next step should look like this. And finally, we can get our final answer by combining the remaining like terms. And we're going to get negative 17 minus 17i all over 34. Now in this problem, we can simplify negative 17 and 34. That's going to be negative 1 over 2. And same thing right here. That's going to be negative 1 over 2 with an I. To find the product of a 2 by 3 term polynomial, I'm going to do the box method. So I will draw a 2 by 3 box. On the side, I'll have 5x and negative 3. On the top, I'll have x to the third, negative 5x, and 2. So we multiply together. 5x times x to the third is 5x to the fourth. Remember, you're multiplying the big numbers and adding the exponents together. So 5 times negative 5 is negative 25. X to the first times x to the first is x to the second. 5 times 2 is 10 with an x. This will be negative 3x to the third. Negative 3 times negative 5 is positive 15 with an x. And negative 3 times 2 is negative 6. So let's combine like terms. Those are the only like terms. So the final answer in standard form, the degrees going from high to low. The x to the fourth comes first, then the x to the third, then the negative 25x squareds. 15 and 10 is 25 x's. And last we have the minus 6. You can also FOIL that. You're welcome to FOIL it. You'll get the same answer. In number 35, we just need to combine like terms. So I'm going to take all the b to the fourths and put them together. I have 5 here and 1 here. And our operation says we're going to add. So 5 plus 1 is 6b to the fourths. Don't change the exponents. Next, I'm going to take the b to the thirds. I have negative 1 right here, and I'm going to add to it 3 of them. So negative 1 plus 3 is positive 2b to the thirds. And last, I'm going to add on negative 3. That's the final answer. Something similar will happen in the next one. Double check your answer to the next one. To find the quotient, we need to divide everything inside the parentheses by 2x to the fourth y. So I'm going to write 2x to the fourth y under each of the terms. Then we can simplify. So 10 divided by 2 is 5. 9 minus 4 is x to the fifth. 5 minus 1 is y to the fourth. Next, negative 18 divided by 2 is negative 9. For the x's, 8 minus 4 is 4. And for the y's, 2 minus 1 is 1. Last, we have 24 divided by 2, which is 12, positive 12. The x to the fourths eliminate each other, and so do the y's. So this is your final answer. On number 38, you should divide everything by 5y. So 5 divided by 5 is 1. 3 minus 1 is y to the second. Negative 10 divided by 5 is negative 2. 2 minus 1 is 1, so y to the first. 25 divided by 5 is 5, and those y's cancel out. Number 39, we need to solve for the zeros, so we're trying to figure out what x equals. We're going to have two answers. The whole thing is set equal to 0. Everything's on one side. So I'm going to go ahead and try to break it up into two factors and see if I can find factors of 3 that subtract to get positive 2. And we can do that. If we do 3 minus 1, we get positive 2. Those are the factors we actually want to solve for what x equals. So we flip the signs, and x equals negative 3 and positive 1. Number 40, we need to solve for what x equals. It says by factoring, so the whole thing is set equal to 0. We need to look for a GCF, because I see a lot of x's and numbers here. The leading coefficient's negative, so I'm for sure going to divide by a negative. And the most letters we can divide each of the terms by is x to the third. So that's the GCF. I'm going to write it out front and write the leftovers next to it. Negative 1 divided by negative 1 is positive 1. And 5 minus 3 is x to the second. Positive 5 divided by negative 1 is negative 5. 4 minus 3, is x to the third. X to the first. And last, negative 6 divided by negative 1 is positive 6. And those x to the thirds cancel out. So now we try to factor what's left inside the parentheses. So what two factors got multiplied together? Well, we need the factors of 6 to add up to -5. We can't add 1 and 6 to get -5, but we can add 2 and 3 to get -5 if we make both of them negative. So the last step is to set all the factors equal to 0 and solve, which means the x's out here will equal 0. This will equal +2, and this will equal +3. If you're ever unsure, you can always graph that and just look and see where the graph crosses the x-axis. To find all the roots in 41, which means we need to find 4 answers. So I noticed that these are both perfect squares, so I know I can factor this into x squared plus 9, because that's the square root of 81, and x squared minus 9. That means that these 9s multiply to get -81, but they cancel out, and that's why there's nothing in the middle. So I'm going to take each of those factors and set them equal to 0, which means the first one, x squared, will equal -9, and the second one will equal +9, and we have one more step to get x all by itself. When we square root both sides, we get plus or minus. The square root of 9 is 3, and the square root of a negative is I. So there's 2 answers. And when we square root the other equation, we get x equals plus or minus 3. So there's all 4 roots. 2 real, 2 imaginary. For this last problem, we need to not only solve it, but we need to state the multiplicity of the roots. So it's set equal to 0. I'm looking for a GCF. It's going to be -4 for the numbers and x to the third. So I'm going to write -4x to the third out front and put the leftovers in parentheses. -4 divided by -4 is 1. X to the fifth divided by x to the third is x squared. -4 divided by -4 is +1. And x to the fourth divided by x to the third is x. And +48 divided by -4 is -12. And those x's cancel out. So we recopy the beginning. I'm trying to find the 2 factors that got multiplied together to get this. So I'm looking for factors of 12 that subtract to get 1. Well, it's not 1 and 12, it's not 2 and 6, but it is 3 and 4. So how can we subtract those to get 1? +1? We need to do 4 minus 3. So one more step is to set each of these equal to 0, which means x is going to equal 0, and since this was x to the third, it means there's 3 x's that equal 0. So we say this has multiplicity 3. X will equal -4 with a multiplicity of 1, because there's only one x right there. And the last one, x equals +3. And that also has multiplicity 1, because it was just 1x. So there's the final answer.